Unit 9, Quadratic Relations and Conic Functions. Section 1 is titled Quadratic Relations. So far we've already talked about quadratic functions in the past, but now this section will include relations as well. To review the difference between functions and relations, a function is a specific relation where for every x value there's one unique y value. So how I remember it is if it passes the vertical line test or not. Graph relation is a function because it passes the vertical line test. Right here you can see that for each x value there is only one unique y value. So it crosses, the vertical lines only cross the equation once. In this relation, you can see through the vertical line test the graphed relation crosses the line twice. So for one x value, there's two unique y's. Therefore, this is a relation. I'll just put an R. This is a function. Right here, again, it passes the vertical line test. For each x value, there's a unique y value. This is a function. This is a function here. This does not pass the vertical line test. This is a relation. It passes the vertical line test. This is a function. Both of these right here are graph parabolas. One is a relation, does not pass the vertical line test, and one is a function that does. But both graphed relations are parabolas. And this is what you will be graphing in this section. Let's graph the relation 4y equals negative x squared. First I'm going to divide by 4 on both sides. And I would get y equals negative 1/4 x squared. I'm going to pick nice numbers to plug in to get rid of negative 1/4. So I'm going to plug in negative 4, negative 2, 0, 2, 4. If I plug in negative 4, I get negative 1/4. Negative 4 squared is 16. And negative 1/4 of 16 would equal negative 4. If I plug in 2, I get negative 1/4. Negative 2 squared is 4. And I would get negative 1. Negative 1/4 times 0 squared. 0 squared is 0. 0 times anything is 0. Gives me 0. And then we're going to start having some reflection. Negative 1/4. 2 squared is 4. And I'm going to get negative 1 again. Negative 1/4. 4 squared is 16. And then again I will get negative 4. So now let's graph this equation. 0, negative 2, negative 1, negative 4, negative 4. Graph the other side, 2, negative 1, 4, negative 4. And here we have a parabola facing downwards. This parabola is indeed a function because it passes the vertical line test. Alright, now let's graph an example 2, the relation negative 8x equals y squared. I'm going to put y squared first. Example 2, let's graph the relation negative 8x equals y squared. I'm going to put y squared first. Y squared equals negative 8x. Now, to get y alone, we need to take the square root of both sides. And you would get two distinct equations. Y equals plus or minus negative 8x. Because when you take the square root, you get a positive and negative version. So this creates two unique equations. Y1 being square root of negative x, and y2 equaling negative 8x. So, all right, y2, y1. Numbers that I can't put into this. Positive. I can't plug in positive 1 because I'll get square root of negative 8. That's not a real number. I can't plug negative 1 or positive 1 into this one either. So then I'm restricted here. The domain, if you're looking at this, is all real numbers where x is less than or equal to 0. So I'm going to plug in 0 into both functions, negative 1, negative 2, should be enough to graph our equation. So if I plug in 0 into the first one, I get square root of 0, so that would be 0. If I plug into this one, I get negative square root of 0, which is also 0. If I plug in negative 1, I'm going to get square root of 8, which equals 2 root 2. And this one I'll get the negative version of that, negative 2 root 2. If I plug in negative 2, I'm going to get square root of 16, which equals 4. And with this one, I would get negative square root of 16, or negative 4. So now, this should be enough actually here to plot our points. I'm going to plot key points here, like 0 and negative 2, because they yield nice results, 0, negative 4. So we have, if I plug in 0, 0, we get this. And if I go, this is negative 2, I'm going to get two answers. We're going to get 4, and we'll get negative 4. So I'll plot this point and this point here. And here is the graphed relation. This is not a function because it would not pass the vertical line test. But this is a parabola that opens left. Example 3. Let's graph the relation negative 5x plus 1/3 equals y squared. Now what's important here is to get y squared by itself. So I'm going to first, let me write it down, negative 5x plus 1/3 y squared equals 0. So I'm going to add 5x to both sides. And I would get 1/3 y squared equals 5x. The next thing I want to do is multiply both sides by 3. Then I would get y squared equals 15x. Then I would take the square root of both sides, and I would get y equals two distinct equations. Y1 equals the positive square root of 15x, and y2 would equal the negative square root of 15x. So let's see what would be nice numbers I can plug in here. 0 would be a good one, of course. Now in this case, the domain, it would be all real numbers where x is greater or equal to 0, because I can't plug in any negative numbers or I'd get a negative under the square root. So I can plug in 0, I can plug in 1, 2, 3, 4. And all I really care about these graphs is for you to get the general shape, so we can do this. I'll just use these 2 points. So we would have 0, 0, and then if I go over here to 1, this would be a positive square root 15 and a negative square root 15. Well, I know the square root of 9 is 3. and the square root of 16 is 4. So this is going to be much closer to 4, but it's not exactly 4. And then we'll have negative square root of 15 would be close to negative 4. So this is a relation that opens to the right. And that's it.